So the first type of factor, what we're moving into is factoring. The first type of factoring that we're going to look at is called greatest common factor, or you see it abbreviated GCF. What does greatest mean? Go ahead and close the Chromebook. The biggest. All right, go ahead and close the Chromebook, please. So it's the largest number or variable that you can divide out of everything. Now, Desmos will do the numbers for you, but it won't do the variables, okay? Let me show you how you can type this in the calculator. First, I'm going to just throw it out there and see what I get back, and then I'll show you how to type it in the calculator. So we want the greatest common factor between 18 and 12. You need to have some number sense here. And number sense is not something I can teach you. It's something you get by practice, right? You need the biggest number that you can divide out of both of those. What do you guys think? 6 is correct. What's 18 divided by 6? It's 3, and 12 divided by 6 is 2. So your greatest common factor is 6. Hey, look it. Show you how to type into Desmos. Are you looking? GCF, parenthesis, and then what were the two numbers? 18 and 12? 18 comma 12. You see that, how it tells you 6? So it'll do the numbers for you. It won't do the variables. The first one is all numbers, so I can put it in the calculator, but I want you to start to build your number sets. Can you guys think of a number that would go into all three of these? I just want you to use your brain and try. Will 9 go into all of them? Okay, let's see if you all are right. Let me come over here. GCF. I'm going to type in 18, 63, V1. 9 is correct. Good job. Now, these other ones have variables in them. So listen, I'm going to put a little star over here. For variables, so that's like X and Y and stuff, you want the smallest exponent. And usually right about there is when I get, but Miss Cole, you said it was greatest common factor. Why do we want the smallest exponent? It's because they have to share it in common. In common. Can you take $5 from someone that only has 4? No. Okay, like it has to be there in order for you to take it. So let's do the numbers first. Greatest common factor between 3 and 24. What could you divide out of both of those? 3 is correct. We didn't need the calculator. We got that. Now, do you see how this is x to the third and x to the second? The most you can take is x to the second. It's going to be the smallest one. The reason it can't be 3 is, can you take $3 from someone that only has 2? No, they have to have it in common. All right, so looking at the next one, let's do the numbers first. You have 10 and you have 15. What is a number that you could divide out of both of those? 5. Now we're going to look at this. This one has 2. This one only has 1. You want to put a 1 there. So what's the most you can take? Listen to what I just explained to you. Just x, x to the 1. Do you see how this is 2 and this is 1? And I told you had to take what? Did you need something to write with? Oh, okay, I'll probably write this down. All right, then look at the y's. Do you see how this one has 4 and this one has 2? Which one are we going to do? Good, because that's the smallest one. Thank you. Now we're going to actually factor. There we were just deciding what the greatest common factor is. Now we're going to actually factor it out. Go distributing. You take something and distribute it through the parentheses. This is just that, but backwards. You're going to undistribute. So instead of multiplying, you're going to divide. So look at these two. You have a 5 and you have a 30. What can you divide out of both of them? 5. Good job. Now, do they share an x in common? Do they both have an x? No, so you can't take x. You can't take it if it isn't there. Do they both share a y in common? No, you can't take y from 5x. There isn't a y there, so it's just 5. So here's how it gets written. You put a 5, put parentheses, leave a little blank there, and you're going to divide both of these by 5. You're just going to divide them both by 5. So what's left in the first one? You have 5x, but you divided out the 5. So what's left? Like literally just x. You can put a 1 in front of it if you want. Plus, now look at the second one. You have 30y divided by 5, which would be 6y. Good job. Now look, because I want you to understand what we actually did. If you took 5 and distributed it through there, what would you get? 5x. Do you see how that's the original problem? We undistributed. You did it backwards. All right, let's try it again. You have 40, you have 30, and you have 20. What can you divide out of all of them? 10. Good job. Now I see some h's in there. Can I take h out? Do they all have an h? No. Do you see how this one doesn't have it? You can't take it if it's not there. So just 10. So you're going to put 10, put a parenthesis, like leave a blank, and you're going to divide them all by 10. So you are undistributing the 10 is what you're doing. You're doing what we did before, but backwards, right? So what's left in the first one? Good, you're getting it. 4h squared minus 3h, good, plus 20 divided by 10 is 2. Now look, if you were to take the 10 and distribute it back through there, do you see how you would get what the original problem is? We just did that backwards. All right, we're going to do a couple more. You have 3, you have 36, and you have 12. What can you divide out of all of them? 3. Now, again, you guys are figuring it out without me having to pull up the calculator, but you understand you could type that in as well. Calculator will do numbers. It won't do the variables. Now, can you take an x out of all of them? No. Why not? 12 doesn't have it. Cool. So put 3, put your parentheses. We're going to divide them all by 3. All right, so what's left for your first term? Just x squared. We divided out the 3 minus, does anyone know 36 divided by 3? If not, I'll tell you. Good, 12. And what's still with that one? X, good, plus, good, 12 divided by 3 is 4. And again, if you were to distribute the 3 through there, you would get what you started with. All right, we'll do this one and we'll do a few on the other side, and then I'll give you a halfway break, all right? 25, 30, and 10. Good, you can divide 5 out of all of them. Anything else? Do they share anything else in common? No, good, so just 5. Sometimes you can take variables though, and you'll see I have a whole page of practice on the other side. So if you divide them all by 5, what are you left with? All right, 5x squared, good, minus 6x, good, plus 2. Very good, we're getting it. All right, we'll do like until I feel like stopping, and then I'll give you a break, okay? So 5x plus 10, what can you divide out of both of them? Put 5, start your parentheses. Now the goal is for you not to have to write divided by 5 every single time. You want to try to remove those training wheels. So I'm going to try and do this one without writing it and see if you guys can get it. If you divide this one by 5, it will just be x plus, and good, why is it 2? Because that's 100% correct. 10 divided by 5 is 2. All right, looking at this one, what can you divide out of both of them? 3. Good job. Now, if you want to write divide 3, that's fine. I just eventually want you to be able to not have to do that every single time. Just trying to save you some work. So if you take this first term and divide it by 3, 2x, yeah, minus 3. 9 divided by 3 is 3. Good job. Let's do a couple more. I'm going to get to one where you actually have to do variables. All right, 18 and 6. They'll both divide by what? 6. Anything else? Nope. So put 6, put a parenthesis. You're going to divide them both, but you're undistributing a 6. Divide them both by 6. So that'll be 3y. Now, this is a little tricky. Here, I'll write the divided by 6 so that you can see it. Oh, I guess it's not tricky. You guys got it. Why is it 1? 6 divided by 6 is 1. You will not believe how often people forget to put the 1 there, so just be really careful. All right, 12 and 21. What do you think? We might need the calculator for that one, but you want to give it a guess? It is 3. GCF for 12 21. 3. Good job. Okay, now hold on. There is something else they have in common. What else have they both got? X. Good. So you can take 3x out of both of them. So here, I'll write this one so that you can see it, because this is the first one we're doing that has an actual variable in it. So looking at the first one, 12 divided by 3. Oh, yeah, go ahead. I think you're ahead of me. Can you let me finish this? And I think I'll probably answer your question. You just hold on a second. All right, 12 divided by 3 be 4. And if you have an x squared and you divide out an x, it's just x. Do you remember your tug of war? It's exactly like that. Minus, does anyone know 21 divide 3? If not, I'll tell you. It is 7. And the x's cancel. They're gone. Don't write it. And again, if you were to distribute this back through there, you would get what the original problem was. All right, so looking at number 5, you have 6 and you have 18. What can you divide out of both of them? 6. Anything else? No. Yeah, this one doesn't have a B and this one doesn't have an A, so they don't share them in common. So all you can take is 6. So if you divide them both by 6, 1B or just B minus 3A. Good. 18 divided by 6 is 3. All right, how about this one? What can you divide out of all of these? 5. You guys are getting the hang of this. This is good. So you're going to divide all 3 of them by 5. So 1y squared, or just y squared, minus 1y. Good. 5 divided by 5 is 1. Plus 4. Good. 20 divided by 5 is 4. This is going well. You just have to listen to me. Good job. All right, what do these share in common? What have they both got? A. They both have an A. You're going to put A off to the side, and you're undistributing the A. You're just removing the A, basically, is what's happening. So x plus 5. Good job. If you still want to write this, you can. The A's are just canceling out. Can you close that for me, pretty please? All right. What can you divide? Or can you divide anything out of both 3 and 5? No, so forget it. What do they both have then? X. They both have an X. So we're going to undistribute an X. So here, if you want to write it, you can put your X's there. Again, I want you to eventually get to the point where you don't have to do that all the time, just less writing. So what's left in this one? 3, just X. Play your tug of war. The top wins by 1. Or you could think of it like one of the X's cancels. Or you could think of it as 2 minus 1 is 1. There's a lot of ways you could think about that. Yes. Yes. So for this one, okay. All right. So for this one, the X's just cancel, and all you're left with is 5y. They just go away. All right. How about this one? What can you divide out of both of these? 9. Are you sure you're okay? I'm going to stop asking then. All right. So dividing them both by 9, you would be left with, 1x squared minus 9. Good job. Couple more. These go quick if you're listening to me. All right. 10, 5, and 45. They will all divide by 5. Good job. Why can't you also take x? 45 hasn't got one. You can't take it if it's not there. All right. So dividing these all by 5 be 2x squared. Good. Minus just 1x. 9. 45 divided by 5 gives you 9. Go ahead and flip over. You guys are doing really well with this. All right. 38 and 10. You come up with a number that goes into all of them. I think I heard somebody say it, but look, I'm going to type it in. 38 and is 2. Good job. 2. So can you take anything else besides 2? Let me take x. Sorry, I had to get back to the 3. Just 2. All right, so we're going to divide them all by 2. So 30 divided by 2. So 15x squared minus, let me finish this one and then I'll answer that. 4x, 8 divided by 2 is 4, plus 5. Good job. Go ahead, question. They have to all share it in common. Do you see how the 10 doesn't have an x? So I can't take out an x if it's not there.
As the 16x, where, how come some of my questions we don't put?
We didn't take an x out of this one, so it's not going to change.
Oh.
Like we didn't take an x out, so that part doesn't change. It just stays the same. But watch, on this one it will. Hey, 3, 6, 12. What can you divide out of all of them? 3. Now you can take out x for this one because that one has an x. They all have an x. So look, I'll write it for you. If you want to divide 3x on all of them. Again, eventually I want you to not have to do that, but I'll show you so that you can see it. So for this first one, 3 divided by 3 is 1. You could put a 1 if you want. Good. Why is it x squared? Yes, 3 minus 1 is 2. You can think of it that way, or one of the x's canceled. Minus 2, good job, and just an x. 2 minus 1 is 1. Plus just 4. These x's cancel. Good job. Good job. All right. The next type of factoring that we're going to do, there's a lot of different types of factoring, and factoring is what we're getting into here. The next type of factoring, you have to be able to do this. It's called Xbox is what we call it, or you could call it magic numbers or whatever. We're just going to practice this now, and then next time I'll show you how to do the factoring. What you need to do is come up with 2 numbers, and this is number sense, which again, I cannot teach. I'll wait till you're done talking. Done talking? All right. I can't teach you number sense. You can use the calculator a little bit, but basically it's something that you have to practice until you gain some number sense. You want the top number to be product. What does product mean? Multiplication. And you want the bottom cell to be sum, which means addition. Okay, there's 4 ways this can turn out. So I want you to draw 4 X's, and I'll show you like the 4 options of the way that this can go. I didn't even do a problem yet, so there's no way that you've got it yet. Okay, so can you just hold on? All right. If your top number is positive and your bottom number is positive, if they are both positive, then both your numbers will be positive. I hope that that makes sense. A positive times a positive is positive, and a positive plus a positive is positive. Are we good? Okay. If the top number is positive, but the bottom number is negative, they are both negative because, listen, a negative times a negative is positive. But if you add 2 negative numbers, it's a negative result. Good job. If the top number is negative and the bottom number is positive, hold on, I'm gonna explain it, just wait. If the top number is negative, you need 1 of each because a positive times a negative is how you get negative. Are you with me there? Now, if the bottom number is positive, that means the bigger one needs to be positive and the smaller one needs to be negative. The bigger number needs to be positive and the smaller number needs to be negative. That's how you end up with, when you add them, you'll get a positive result. Now, if they're both negative, again, you want 1 of each. But in order to end up with a negative number when you add them together, the bigger one needs to be negative and the smaller one needs to be positive. Now, I wrote all that out for you, but it's going to be intuitive. It's going to make sense once we put some actual numbers in there, okay? Let's just try a few. You're listening here? Don't talk over me. So the first one, let's just look at the top number. You need 2 numbers that multiply together to be 12, but you need them to add together to be 7. So good, it will be 3 and 4. 3 times 4 is 12, but 3 plus 4 is 7. For this one, let's look just at the top number. You need 2 numbers that multiply together to be 27, but they need to add together to be 12. It will be 9 times 3. Now, hold on. Don't talk over me. You are like, hey, I'm stuck. You remember with the radicals, the square roots and the cube roots? Okay. You can take the top number, which was 27. Are you all looking here? Divide by x. And how did we make the table? Year table. Now, if you keep going, do you see how you find 9 and 3 on there? 9 plus 3 is 12. You can use that if the numbers get large or you just don't know what it is. All right. You need numbers that multiply to be 15, but add up to be 8. 3 and 5. Good job. Now here we're going to start doing some negatives, so you got to be careful. I need numbers that multiply to be 8, but add up to be -9. So it cannot be 2 and 4, because 2 plus 4 isn't -9. What else? They are both going to be negative. What else multiplies to be 8 besides 2 times 4? I'm not even looking at negatives yet. Just what are some other numbers that multiply together to be 8? I just said it's not 2. It can't be 2 times 4. 8 times 1. Thank you. And then they're both going to be negative because, and come with me on this, negative times a negative, don't talk over me, is a positive, but -8 plus -1 gives you -9. All right, let's try again. I need numbers that multiply to be 16, that add up to be -10. So 16 plus 1 is not going to be -10. So it cannot be 16 and 1. What else multiplies to be, what? So 4 and 4 will not add up to be 10. What, 4 times 10 isn't 16. There we go, thank you. 8 times 2 is 16, but what? They're negative, because -8 plus -2 is -10. I think we're getting there. We just need to stop shouting out random things, all right? 30, I need numbers that multiply together to be 30. 10 and 3, good job. 10 times 3 is 30, but what? They're both negative. -10 plus -3 is -13. There, we're making some forward progress. Try a couple more. Now, do you see how the top number is negative? Shh, shh, be quiet. That means you need one of each. You're going to have one that's positive and one that's negative. What are some numbers that multiply to be 35? 2 will not go into 35. 35 is not 5. Thank you, whoever said 5. 5 times 7. Good job. One of them's negative. Now listen. In order to listen, you need to not talk. You can't do both at the same time. No. It will be -5 because, listen, 7, +7 minus 5 is 2. There we go. If I made the 7 negative instead, then it would need to be -2. Good job. All right. I need numbers that multiply together to equal 11. There's only one option. 11 and 1. It's a prime number, so it has to be 11 and 1. Now, which one gets the negative so that I add them to give a -10? The 11. -11 plus 1 gives you -10. Again, you're going to need one of each. I need numbers that multiply to be 12. It will be 2 times what? 6. 2 times 6 is 12. One of them is going to be negative. Why is the 2 negative? 6 minus 2 equals 4.